Okay, so I've not done a voiceover in a long time, but let's try. Just want to talk about two things, rendering and movement physics. First, let's start with rendering. Rendering is mostly finished for this project. If I can find my debug block, which is pure white. There is ambient occlusion, and I don't think I'm going to add per block light propagation, since it's too much work. Don't really want to have feature creep on me for this project, since it's just meant to be an example game. So ambient occlusion works very nicely. It also supports flipping the quads if you're at diagonal edges. I've seen some voxel projects that don't do that. Doesn't really make sense. It's very easy to implement. It makes it perfectly smooth. Otherwise, you get in one of the diagonals, you get strange lines. And if you take a look at the orientation of the triangles there, if I remove the block, then you see now it's perfectly aligned with all the others. But if I place a block here, it gets flipped, just so we can get a perfectly nice, smooth corner for all the four corners. Yes, transparent blocks are also supported, but just alpha testing transparency. Also for sprite blocks, of course. And glass blocks work just fine. Still have to remove the in-between faces. But yeah, so this is easy to add because it's working with the depth buffer. If you wanted proper transparency with blending, that's a bit harder. I still have to add that for water blocks. And this will need a separate rendering pass. So first you render all the opaque geometry and then you render the transparent stuff. But at least you only need one pass if you don't want multiple blending between multiple different things. So for water, it's fine to just have one extra rendering pass. Yes, and also camera frustum culling. I also still want to implement that because it's more or less free performance since you're never seeing all the chunks at the same time. Except maybe if you fly to the top and then look down. It's a worst case scenario for frustum culling, but it should be good enough for this case. Okay, let's take a quick look at movement physics. I'll just switch to the flat world. This one is interesting because I've tested Minecraft a little bit, and it seems that they just have to wait until all the generation is done because I don't have priority on the workers yet. So in Minecraft, they just clip the velocity against the AABBs. This has some side effects if you do it just like this. Let's see, in Minecraft we have 20 ticks per second, so this means that the game updates 20 times per second, which gives like 50 milliseconds, I think, per tick. And this also means that if you move very quickly, then the clipping can basically push you to the other side or push you through blocks. Yeah, if I move very quickly, even though I'm just moving in a perfectly straight line to this orange block there, at some point I get pushed to the right for no apparent reason, even though I'm just walking forward and back. Doesn't make any sense. I can replicate the bug. Currently I have the logic that fixes it disabled on my side. So if we increase the player movement speed, let's say 100, and also this game is not running tick-based, so every frame you see is the exact time that the game logic has been updated for. So I'll just limit the FPS to 20. And yeah, let's put a indicator block at the other side there. So I'll just move forward and back again. And bam, we also get pushed to the side. Depending on which orientation you're in, you get pushed to the left or to the right. And how to fix this is not that hard. You just add a swapped ABB test before you do the clipping, or the ABB velocity clipping. And this will fix the problem. Let's compile again and try the same thing. Increase the movement speed again. 100 FPS. Or first let's place the blocks. So I don't really understand why they never fixed this in Minecraft. I mean, I guess if you're not too fast, then it shouldn't be a problem if the tick stays small enough, since the tick rate is fixed. But I don't know. Feels like a missed opportunity. And let's do the same here. And now, regardless of how fast I'm moving, let's increase the movement speed to like 1000 units per tick. And like we're moving really fast now. If I crouch and move slightly back and then full forward, it's no matter how fast I'm moving, the collisions are perfect, basically. Yeah. You can also see the collision box of the player. movement speed is still too fast. 4.5. Yeah. It's the same size as in Minecraft and also the same height. I think 1.8. So collisions are pretty much done, working perfectly, irregardless of speed or tick rate. And I also added strafe jumping. If you take a look at the velocity 2D at the top right, I'll try to do a strafe jump. I'm not the best at this, but should be good enough for a demonstration. Yeah. Just for fun, little gameplay mechanical quirk from Quake. And the way this works is that instead of, if you accelerate in the acceleration function, instead of just accelerating to the maximum speed you currently have set, depending on crouching or sprinting or whatever, you limit to the projection of the wished direction. The wished direction is based on your key inputs, and you project that onto the velocity, and then you accelerate by that as the speed limit. And this means you can exceed the actual speed limit, and it makes for some very interesting gameplay. And I also added accelerated backhopping from Half-Life 2, because why not? It's also a fun gameplay mechanic, or actually a bug they tried to fix bunny hopping, and the result was accelerated backhopping. And the reason this happens is the APH code gives a slight boost. If you again take a look at velocity 2D, the top right, I'm walking now 4.5, and then if I jump, I get a slight jump boost. And so the bug lies in the jump boost logic. And the reason it's a bug is because if you jump, then it applies the boost and tries to limit the boost based on your viewing direction. And this means if you jump and then you look backwards in the opposite direction of where you're going actually, then it will add a negative velocity, which means it will add velocity instead of slowing you down, and this grows exponentially faster the more times you jump. And accelerated side hopping also works, so ASHing just fine. It's a little bit easier to do here compared to Half-Life 2 because the friction values and acceleration values are different. So depending on the air acceleration and air friction and ground acceleration, ground friction, this feels different. But yeah, a lot of fun to play around with. And that's it for now.